Okay, this introduction says that the crew is beginning to realize how expensive it is being groupies. They see that they only have $570 left in their concert fund. They are still planning on going to Minneapolis, where the tickets were $80 and then it was $250 for gas. So the question is, how many people can go if they plan to use all of their money? Well, we know that we have $570 to spend. Okay, we know that we're going to have to use $250 of that for gas. So since we're using that money, let's go ahead and get rid of $250 that we know we're going to have to pay for gas, which gives us $320 left. Okay, well, that $320 we're going to have to split into groups of 80 to see how many people, how many tickets we can buy out of that 320. So when we group things, that's actually dividing. And start getting used to using a line for division because it's the easiest way to solve equations, which is what we're going to do in this problem or in this section. So I have $320 and I want to divide that into groups of 80 to see how many tickets I can buy. Well, 320 divided by 80 is 4. So it looks like 4 people can go. Okay, that's one way that we can solve this problem. Another way is to look at our little function machine. We set up this function machine as saying that whatever number we drop in, we have to multiply by 80. And then whatever number gets spit out of that, we're going to add 250. And usually we know what we're going to drop in and then we get a number at the end. Well, this is different. We actually get the number at the end. So we know that 570 was spit out of our machine. So we have to figure out what was put in there. Well, this is when we hit the reverse button on our function machine. So we're going to take this 570 and we're going to suck it back through the machine to figure out what came up here. Well, when you hit the reverse button, that means we're going to do the opposite of what it says here. So 570, instead of adding 250, I'm going to subtract that. I'm going to reverse it through, and I'm going to get 320, like we did over here. So keep going. We're almost done with one more step, reversing that through. Again, instead of multiplying by 80, I'm going to do the opposite, and I'm going to divide that by 80 and get 4, which is what I got right there. So that's way number 2 on how to solve this problem. The third one, I'm going to show you the algebraic way. So remember that when we wrote an expression for this, we said that it was $80 per person plus the $250 for gas. Okay, we know that that total now is going to equal 570. So we just wrote an equation. Now what we're going to do, again, is figure out how many people. So we're going to look at this side and we're going to undo everything around that variable in order to figure out what was in there. So we're going to, again, undo. How do I get rid of a 250, a positive 250? Well, I'm going to subtract 250. Okay, when we throw an equal sign into a problem, we have to realize that we're on a teeter-totter. So if I subtract 250 on one side, now all of a sudden I have too much on this side. And that equal sign means I always have to keep everything balanced. So if I subtract 250 from one side, I have to subtract it from the other side to make my teeter-totter balanced again. So now I'm going to work left to right and figure out what I have left. I still have an 80 times P. I actually undid this, and that was my whole goal. It was to get rid of that because positive 250 minus 250 is 0. And I'm not going to put that in there. I'm just going to know that that's 0. 570 minus 250, we decided was 320. Okay, last thing that I have to undo is this 80. Again, say in your mind, what am I doing between this 80 and the P? I'm multiplying. So opposite of multiplication is division with my fancy line here. So I'm going to divide an 80 out on both sides to keep my teeter-totter balanced. So 80 over 80 is 1, which is what we want. We want 1p. So 1p equals 4. Again, 3 different ways to solve this problem, and I ended up with the same answer all 3 ways. Looking at number 2, it says, while researching online, one of the group members finds a great deal. We Love Music members can purchase tickets for half price. They were smart after the last concert, and all of the groupies are now members. So the question is, if they purchase the special tickets, how many people can go if they plan to use all of their money? All right, well, we're going to look at the numbers that we used up here. Instead of $80 for tickets, now we're going to say it's $40 for tickets. Still have to pay the same price for gas, so we still have to pay that $250 for gas. And we know that we still have 570 total. Okay, I'm going to go ahead and go straight to my function machine on this one. Again, $40 for tickets. So instead of multiplying by 80, I'm then going to set up a machine that multiplies by 40, and then I'm going to add a 250. Same thing as last time. We actually know what was spit out of the machine. We know that we end with 570. So I'm going to hit that reverse button again and go through the process. 570, reversing a positive 250, we're going to subtract that. So that's where our 320 came into play. And again, still going through the machine, 320 reversing, multiplying by 40. So I'm going to divide by that, and I end up with 8. Let's go ahead and set up an equation and solve it to see if we get the same answer. So again, $40 per person for tickets. So $40 per person. I have to add on $250 for gas for the whole group, and I know that I have $570. So here's my equation. I'm going to solve for this variable. So I'm going to undo everything around it. So to undo a positive 250, that's when I subtracted. I drop down that 40p. They are gone, and I end up with 320. Again, I realize that this is multiplication, so I'm dividing by that 40 on each side using that division sign. These disappear and leave me with 1p, which gives me 8. So 8 people can go on our little trip. And that is our goal of this section, is to set up equations and to solve them by working backwards. Go ahead and get out your notes and vocab for this section. Okay, the objective of this section is to solve one variable linear equations with rational number coefficients. And remember, coefficients are that number in front of the variable. So we dealt with 80 and we dealt with 40 as our coefficients. We are also going to solve real-world problems involving linear equations, and we actually just did that. So looking at this next part, it says since the intro equation requires more than one step to solve, it's called a multi-step equation because we had to subtract and then we had to divide. So again, to solve these equations, we're going to work backwards. We're going to hit that reverse button and undo everything around that variable. Notice over here to the right, I wrote something kind of weird. I wrote SADNEP. Because basically, again, working backwards, we're going to work through the order of operations backwards. So most of the time, we are going to subtract and add first, which we did. We subtracted that 250. Then we're going to divide or multiply. And again, we divided off the 80 or the 40. Notice here I said unless the division prevents us from adding or subtracting first. So sometimes, of course, there's always that stipulation, and we're going to get to that in this next problem. So let's go ahead and look at example 1. It says solve each equation. Anytime that you see the word solve, that means we want to get the variable by itself. We want to undo everything around it. So looking at A. Again, first step here, we're going to add or subtract. Here we are actually subtracting a 4. So again, the opposite of subtraction is addition. I want to add a 4 to each side in order to cancel that out. Remember, I'm adding it to each side. I have a teeter-totter that I have to keep balanced. So working left to right, actually, I told myself not to do this bad habit. What we want to do first is rewrite the equation. Get it out of the way of everything else. Then we can go ahead and work on it. One of the biggest fallbacks of solving equations is to get really sloppy and have all of the steps all over the place. Try to keep them as linear as possible and have them go straight down the problem or straight down the page. Okay, so now Now I'm going to add 4 to each side. So I have 11x, my 4 is canceled, and I end up, goodness gracious, don't get sloppy and make sure that you write the problem correctly. I end up with 33. Okay, if you're not quite sure what operation to do next, go ahead and look at the problem. This is saying 11 times x. So how do I undo multiplication? I'm going to divide by 11 on each side. So 11's cancel. I'm left with 1x. 33 divided by 11 is 3. And it does say check your solution. So if you want to, go ahead and take this 3, drop it back into the machine, and make sure you get out the correct answer. So 11 times 3 is 33. 33 minus 4 is 29. So x is the correct number that was dropped into the machine in order to get out of 29. All right, go ahead and look at B. This is where that little stipulation comes into play. Notice that we have a plus 7, and all of that is being divided by the 8. So we can't subtract a 7 over yet because that 8 is in the way. So again, step 1, I'm going to rewrite this. So I have an a plus 7 divided by 8, and that equals 5. So the reason why I say that in my brain, because I'm dividing that whole thing by 8. What's the opposite of division? Multiplication. So I'm going to multiply both sides by an 8. And again, the reason why I did that, this kind of visualize that this is the numerator and the denominator. So those 8's cancel out, and I'm left with an a plus 7, and that equals 5 times 8, which is 40. Now I can go ahead and get rid of this 7. It's the only thing in the way of solving and getting that a all by itself. So what's the opposite of a positive 7? We're going to subtract that over. A now is completely by itself. 40 minus 7 is 33. Again, if you want to check that, throw it back into the machine. 33 plus 7 is 40. 40 divided by 8 is 5. So we can go ahead and circle that and say that it is the correct answer. Okay, looking at C, again, I'm going to rewrite this by saying it in my brain. 2b divided by 3 plus a 6 equals 24. Okay, we do have division in this problem, but look at this. It's not in the way of adding or subtracting first. That 6 has nothing to do with this mess over here. So I'm going to go ahead and focus on this 6 first. What's the opposite of addition? I'm going to subtract a 6 from both sides. And I'm left with 2b divided by 3 equals an 18. Okay, I said that in my brain. I have a division here. How do I get rid of division? Just like I did on B, I'm going to multiply both sides by 3. Again, make sure students are understanding that that is a division sign. Here, we could look at it as a fraction, but it helps us understand what operation we're going to do. Okay, so my 3's cancel, which is what I wanted them to do. I'm left with 2b equals 54. 2 times b equals 54. So how do I get rid of multiplication? I'm going to divide. So my 2's cancel. I'm left with a b, and that equals 27. Okay, again, you could throw that back into the problem to make sure that we have the correct answer. Again, we could have looked at that as a fraction. Always many different ways to solve a problem, and we're going to look at how fractions come into play right here. So I'm going to rewrite this real quick. -5/2 equals 3/4 times z plus 1/2. Okay, this is written a little bit differently because notice all of these over here, the variable was on the left. Now we have it on the right. So what are we trying to solve for? Do we go left to right? You always look at the side of the equation that the variable is on. So I am focused on this over here. I'm going to look at what I have. I am adding a 1/2 here. Going up to working backwards, I have to get rid of that. So I'm going to subtract 1/2 from each side. And don't get scared that we're dealing with fractions because look at this. -5/2 minus a 1/2. Since I'm adding the opposite, that's -5 plus a -1, which is a -6/2. So see that as division. -6 divided by 2 is -3. So we end up with -3 on that left side equals 3/4 z. Okay, now we have a problem because we're dealing with a fraction. In order to get rid of a fraction, we want that 3 and that 4 to turn into 1s. Well, how do we do that? We multiply by its reciprocal. And remember, reciprocals are the opposite, or we flip them. So instead of 3 over 4, I'm going to have 4 over 3. And notice what happens. Those 4's disappear, those 3's disappear. So that is going to get rid of the mess over here, and we're just left with a z. Okay, I have to do that to the other side, so I'm multiplying that by a 4 over 3. Here, since I'm dealing with a fraction and a whole number, a lot of times it's really nice to put that whole number over 1, because now I can kind of visually see what I have. I have two fractions since I'm multiplying. I can cross cancel if I need to. So I have 3's that will cancel, which leaves me with just a 1 on each side there. So reading this, I have 4 times the negative 1, which is the negative 4 over 1. Okay, slow and steady. One little problem, like especially right here, if we didn't add that correctly, we could have a problem there. All right, go ahead and try the guided practice, and I will put up the answers. Okay, here's what you should have got. 1A is pretty straightforward. 1B was where that negative 2 is in the way, so we do have to multiply by it. Notice it is negative, so you have to get rid of the negative as well. So multiply by a negative 2 on that one. 1C, if you notice what I did, I actually did 2 steps in one. So I looked at 5x divided by 9 as actually 5/9 x. So I saw 5/9 as a fraction. I multiplied by the reciprocal. So I flipped that and multiplied by 9/5 on each side so I could cancel both of those out at the same time. Same thing on 1D, dealing with those fractions, but multiplying by that reciprocal at the end. One thing I do want to bring up is really be careful and slow down on all of these steps, especially one like this where we have negative 30 minus 1. That is negative 31. You don't want to go through all of these steps and then find out that you have one small little mistake because of something where a negative got in the way. So really do slow down and make sure that your addition, your multiplication, your division is correct. All right, moving on, real world example. Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. So the question is, what's the original price of the skis? We're supposed to write an equation for the problem and then solve it. We should be pretty good at this so far because we've done this already in the intro. What I'm going to do is I'm going to start with the original price. So I'm going to say, I'm going to use P. So P is the original price. Okay, so I'm just going to put P down. I know that that it's on sale for 2/3 of the original price. Well, translating that, 2/3 of means I'm multiplying by 2/3 of the original price. He uses a $25 gift certificate. So uses is kind of a clue word that says I'm going to take that and subtract $25 from it. The total cost before taxes is $115. There's that clue word is. So I know that this is going to equal 115. So there's my equation. Read that one time through and then put it in chunks and figure out where the clue words are and what they mean. So we have our equation. Let's go ahead and solve this, working backwards. We know that we're going to add or subtract first. So I'm going to add 25 to both sides. I'm left with 2/3 P. I know that that equals $140. Again, getting rid of a 2/3. How do I do that? I multiply by the reciprocal. So I'm going to multiply by 3 over 2 for that to completely cancel. I'm going to multiply by a 3 over 2 for this to figure out what the original price is. Again, I'm going to put a 1 over that, and I'm going to do some cross canceling so I don't have to deal with such big numbers. 2 goes into 2 once, into 147 times. I'm 70 times, so 70 times 3 is 210. So original price, I'm going to write it over here because I'm running out of room. Original price is 210. I am kind of a bad example of trying to keep things nice because my handwriting is terrible, but if need be, lined paper is awesome. So you can do each one of those steps on lined paper. The neater it is, the easier it is to go back. Do make sure that you do every single step. Don't think that you can skip a couple steps, because if something happens, it's really hard to go back and figure out where the problem lies. So I do want to make sure I put a dollar sign there so I know that it's $210. All right, go ahead and try guided practice 2A. Okay, translating 2A into an equation, it says 3/5 of the CDs. So I did 3/5 of X because X equals my CDs. They had, but then 10 more were returned to them. So I have to add 10 onto that. Don't subtract it, add it, because it was added into the collection that they had. Okay, now the store has 62, so that has is my equal sign, and then I can go from there. Notice this didn't say write an equation. I like to write equations, but it doesn't say anything about that. So you could have just worked backwards, took 62, subtracted, or added 10 to that to see how many they had, and then multiplied it by 5/3. Okay, looking at 2B, we have 3/4 of a graphic novel. So 3/4 of the pages, 3/4 P, and then he read 22 more pages. So I had to add 22 onto that. Again, he has read, so has is my equal sign, 220. How many pages does the book have? So I just worked backwards on that one. Notice one other thing that I do. I always like to what's called define my variable. So if I'm using P, I want to write down what it is. Really good suggestion to do on story problems, because when I get down to the end, I have P equals 264. Well, if I can't remember what I started with, what does P equal? That's why I had that defining the variable. Oh, I know that I'm going to tag this 264 as pages. I know that this 130 represents CDs. Sometimes they require you to do that, other times they don't, but it is a good thing to do for story problems. Okay, looking at integer problems. I'm just going to go ahead and read this and then explain it. It says consecutive integers are integers in counting order. So consecutive means that the numbers 4, 5, and 6. Notice how we write that algebraically. N is represented as 4. 4 plus 1, or n plus 1, is represented as 5. And then my starting number of 4 plus 2 is 6. Okay, we really need to get used to looking at numbers like that, especially when they don't tell us what the numbers are. We know our starting number is n, which means we're going to add 1 to it to get our second one, and add 2 to it to get our third number. Counting by twos are resulting in either consecutive even integers or consecutive odd integers. So that's going to look a little bit different. Now look down at this nice little chart. Consecutive even integers. I'm going to start with 1. So this could be 4. The next even integer is 6. So I have to add 2 to it this time. The next even integer is 8. So I have to take my starting number of 4 and add 4 to it. Sometimes kind of hard to comprehend, but understand consecutive integers right back to back. So we're just adding 1, 2, and 3, and so on. Sometimes it's every other, so we're adding 2 and 4. Notice that's the same for both even and odd. So if I started with n as being 3, my next odd integer is 5, so I'm still adding 2. My next odd integer is 7, so here 3 plus 4 is 7. Okay, so don't think that I'm adding 3 and 5 there. It's actually still adding 2 and 4. Okay, number theory is the study of numbers and the relationship between them. So basically what we're going to do is we're going to translate this. We're going to write an equation, and then we're going to solve it to see if we can find the answer. So it says we're supposed to find 3 consecutive odd integers with the sum of -51. Okay, so I'm going to use this handy chart. I'm going to find consecutive odd integers right here. So I know that I'm going to start with my first number n. Okay, that number plus the next number in line plus the next odd number in line should give me negative 51 because it says the sum of those. So sum of three numbers. Well, since we're dealing with odd integers, my second number is going to be n plus 2. My third number is going to be n plus 4. Okay, so there's my equation. Three numbers. They're odd integers. That's why I'm adding 2 and 4 to it. And I know that those added together give me negative 51. Now I'm going to have to go ahead and solve this equation. So look at this. I have 1, 2, 3 n's. So I have 3 n's together. And I'm going to add 6 to that. So I just simplified this by combining like terms. And now I have a decent looking equation. I can go ahead and solve this. So I'm going to subtract 6 from both sides. I end up with 3n equals negative 57. And I'm going to divide by 3 on each side. Negative 57 divided by 3 is 21. Okay, hold up for a sec. Okay, now that my math is right, negative 57 divided by 3 is negative 19. Okay, but looking at what I'm supposed to do here is I'm supposed to find the 3 consecutive odd integers. So I know that my first number is negative 19. I know my next one, I have to add 2 to that. So negative 19 plus 2 is negative 17. And then I need to add 4 to negative 19, which is going to give me negative 15. Okay, so make sure that we go back to the problem and say that I know that n equals negative 19. My first number is negative 19, but I'm supposed to find all 3 numbers. So these 3 numbers added together, they are consecutive odd numbers because they're back-to-back odd numbers, and added together give me negative 51. Okay, really use that chart until you get comfortable with understanding the difference between just consecutive numbers and consecutive even and odd integers. All right, go ahead and try guided practice 3. Okay, writing the equation for this, it says find 3 consecutive integers with a sum of 21. So consecutive integers means back to back. We're not skipping numbers. So my first number is n. I add 1 to that number. I add 2 to that number. So I'm not jumping numbers. I have n plus n plus 1 plus n plus 2 equals 21. So there is my equation. I'm going to go ahead and combine terms. I still have my 3 n's, but this time I'm only going to add 3 to it because they're just consecutive integers. So solving this, I understand that n equals 6, but I have to figure out how to use that information. Find 3 consecutive integers. My first number is 6, which means back-to-back 7 and then 8. So those 3 numbers are back-to-back numbers, and they do add up to be 21. All right, solving multi-step equations. Add or subtract first, most of the time, so we subtracted that 3 over. Then multiply or divide in order to get your answer. Once you get that answer, figure out what you're going to do with it. Okay, you are ready for the assignment for this section.